All right, let's talk about the sum and difference formulas for tangent. This time, we're going to start this video a little different. We're going to start this one with an example instead of with a formula. Derive a formula for the tangent of alpha plus beta. And you might say, Jason, that's what we're here to learn. How come you're making me do it? It's because you have all the tools right now. You can do this yourself. But we'll do it together, all right? So remember that tangent of any angle is just sine of that angle divided by the cosine of that angle. So the tangent of some angle, whatever the angle, alpha plus beta is just the sine of that angle divided by the cosine of that angle. And we already have these two formulas. So strap yourselves in. It's algebra time. For anyone who's going on to calculus after this, algebra is the single, trig is important. Algebra is the single most important part of calculus. So anyone who's got calculus in their future, anytime I say the A word, algebra, I had to clarify that really quickly. Covering my bases. Every time I say algebra, you should hone in and say, I need it. That's good practice. So here we are. We just use the formulas. Angle sum formula for sine is sine of the first, cosine of the second, plus cosine of the first, sine of the second. Angle sum for cosine is cosine of the first, cosine of the second, minus sine of the first, sine of the second. And you might say, well, great, Jason. We did it. We derived a formula. And that's actually true. This is a formula. This is a perfectly good formula. But there's a slightly nicer version. And it's a little hard to see where it comes from. And this is the real trick that might stop you from deriving this on your own. We're going to divide the top and the bottom by a bunch of cosines. Why do we want to divide by a bunch of cosines? Because then what's going to happen? If you divide sine by cosine, you get tangent. If you divide cosine by cosine, you get 1. So we're only just going to have ones and tangents instead of sines and cosines. All right. So let's divide the top and the bottom by cosine of the first angle, cosine of the second angle. 1 over cosine of the first angle, cosine of the second angle. We're dividing it on the top and the bottom. And what that's going to give us, because we are going to have to distribute, this is going to be one messy step, but don't worry. It'll get better later. So we have sine alpha cosine beta, just like before. But now that's getting divided by the cosine of alpha times the cosine of beta. And we just do that for every one of these. Every single one left is getting divided by cosine alpha, cosine beta. So we just gotta get to work and copy it all down. Cosine alpha, sine beta, over cosine alpha, cosine beta. This is cosine alpha, cosine beta, divided by cosine alpha, cosine beta. And this is sine alpha, sine beta. Oh, not sim. Sine alpha, sine beta, divided by cosine alpha, cosine beta. So this is a really good opportunity for you to practice some simplification if you want to pause this video and simplify it on your own. But it's actually very quick. It looks super messy, but we're basically done. Why is that? This is a monster. This is like one of those ice cream cookies that has like 4 ice cream cookies in it. I'm hungry. So let's simplify. Cosine over cosine. Specifically cosine of beta over cosine of beta. It has to be the same angle. Cosine alpha over cosine alpha. This whole thing, remember that it doesn't cancel completely. It cancels to 1. And this last thing, nothing cancels. So what are we left with? Sine alpha over cosine alpha. That's just the tangent of alpha. plus sine beta over cosine beta. That's just the tangent of beta. The sine of an angle divided by the cosine of that angle is the tangent of that angle. Divided by 1 minus sine alpha over cosine alpha, tangent alpha. Sine beta over cosine beta. Oh! And there is the angle sum formula for tangent. Proven by you and me together today. All right. So let's generalize it. Another gold box. The tangent of any angle plus or minus some other angle is going to be the tangent of that first angle plus or minus the tangent of that second angle divided by 1 minus or plus the tangent of the first angle times the tangent of the second angle. Let me double check. Yep. Great. We add another gold box to our formula sheet. And again, so if we have tangent of A plus B, we use all the things on the top. And you can see that that is exactly what we had over here. We're just combining two formulas into one. Let's do some problems. Example 5. Given that sine of alpha equals 3/5 and alpha lies in the interval 0 to pi over 2. And we're going to go on, but I don't think I've used this notation before, and I really like the notation, so I want to make a quick comment on. This just means alpha lies in the interval. It's an element sign. It kind of looks like a weird E. And some nice shorthand. So also, the problem is giving us that the cosine of beta is equal to negative 5/13, and beta is in the interval pi to 3 pi over 2. So again, this really just means first quadrant. This really just means third quadrant, between 180 degrees and 270 degrees. I want you to find the following. Part A, the sine of alpha plus beta. So we just use a bunch of formulas. Well, in this problem, we use one formula. So this is going to be the sine of the first, just like in the second video, cosine of the second, plus the cosine of the first times the sine of the second. We know that sine of alpha is 5/3. We know that cosine of beta is negative 5/13. Whoa, sine of alpha is 3/5. Cosine of beta is negative 5/13. Plus the cosine of we don't know the cosine of alpha. It didn't tell us. But we can find it. All right, so we know the sine of alpha is 3/5, and we know that alpha is between 0 and pi over 2. It's going to be like something in the first quadrant. Sine of that is 3/5. You could use Pythagorean theorem to find that this is a 3, 4, 5 triangle. So the cosine of alpha is 4/5. Similarly, we need the sine of beta. We know that beta is in the third quadrant. Negative 5/13 is a cosine. The y-coordinate will also be negative. And again, you could use Pythagorean's theorem to get that this is going to be 12. So negative 12/13 is the sine of beta. And then we just simplify. I'm going to see if I learned my lesson from before. Let's not cancel anything until we combine these fractions, because they already have a common denominator. So let's keep that. It's going to be 65 minus 48 over 65. It's going to be negative 63 over 65. And yeah, that's 9 times 7 and 5 times 13, so that it doesn't reduce. This is the sine of alpha plus beta. Part B, I'm just going to ask you to do something very similar. What's the cosine of alpha plus beta? So again, I highly recommend pause the video, solve this problem just like in the first video of this section, and then see if we get the same answer. Formula says it'll be cosine of the first, cosine of the second, minus the sine of the first, sine of the second. Remember that formula from the first video. And then we just use the stuff that we used before. I don't remember what these were. Sine of alpha is 3/5. I'm going to write these down again. Cosine of alpha was 4/5. We knew that cosine of beta was negative 5/13. And we knew the sine of beta was negative 12/13. We just sub all of this in. Cosine alpha, 4/5, times cosine beta, negative 5/13, minus the sine of alpha, 3/5, times the sine of beta, which is negative 12/13. Simplify to get negative 20/65 plus 36/65. That's going to be 16/65, I believe. And again, it doesn't reduce. All right. Should be the cosine of alpha plus beta. Now, here's the reason that we're really here. Part C, the tangent of alpha plus beta. Now, I'm hoping that you say, Jason, tangent of any angle is just the sine of that angle divided by the cosine of angle. We already did that in the last two problems. That's what I'm hoping you're saying. Let's use the formula. I'm very nervous about part B, but we're going to be able to check our answer here in part C. Let's get some practice with the formula. This is going to be the tangent of alpha plus the tangent of beta divided by 1 minus the tangent of alpha times the tangent of beta. And again, what is the tangent of alpha? Opposite over adjacent, 3/4. What's the tangent of beta? Well, again, opposite over adjacent, 12/5. Tangent is positive in the third quadrant. So tangent of the first, 3/4, plus tangent of the second, 12/5, divided by 1 minus 3/4 times 12/5. And you could simplify this in a variety of ways, but one of the ways to do it is to multiply the top and the bottom by the LCD. Multiply everything by 20/20 and distribute that. Because what that's going to do is the first one becomes 60/4, which is just 15. 3/4 of 20 is 15. This becomes 48 on the second one, I believe, because 20 divided by 5 is 4. 4 times 12 is 48. You can use a calculator for these. 1 times 20 is 20. Shouldn't need a calculator for that one. And the last one is 20 divided by 20. That cancels out. We just have a 36 here. So we add this all together. It's a 63 on the top and a negative 16 on the bottom. Is that the same as sine over cosine? Let's check. Sine of alpha plus beta over the cosine of alpha plus beta. What was that? Sine was part A, negative 63/65. cosine was part B, 16 over 65. Multiply both sides by the top and the bottom by the LCD, which is 65 over 65. The 65s cancel. And so you can see that, yes, if you have sine and cosine already, it's much faster to just do it this way. But it's good practice for using the formula. Whoa, these are the same. Crazy. That's a weird face. That's a weird face. No faces today. All right. So that's the angle sum and difference formula for tangent. You now have angle sum and difference formulas for sine, cosine, and tangent. Throw it all together. Talk about cofunctions. Do some identities. I know everyone loves verifying identities, and have some homework problems afterwards. Hope you're hanging in there. Good luck. And remember, you can always ask me if you have questions. Bye-bye.